Okay, so for today data communication class, we will finish the flow and error control for the synchronous TDM, and then we will go to the multiple channel access. Okay, then we will go to chapter 8, which is the wireless area network. Okay, now for the flow and error control for synchronous TDM, remember that when you do the synchronous TDM, you just move the transmitter and the receiver at the same speed, right? So there is no overhead at all. There's no header. You just look at the time, okay, that this time belongs to which user. And then you know that this is how you share the medium. So how do you control the flow, okay, and the errors? For the flow, since you go at the same speed, you don't need to control the flow, right? Because you design the receiver so that it has the same speed of transmitting as the transmitter. Okay, so no problem with the flow control. How about the error control? For the error control, you can, since we talked about last time that we can have multimedia, right, in the same frame. Channel 1 may send an image, channel 2 may send voice, channel 3 may send file, data file, okay? So some of them may need error control, some of them may not need error control, depend on the users. So we should let the user decide whether it will use the data, the error control or not. Okay, so if we look at the frame, and suppose this channel 3 send data, okay, send data, okay, maybe this one send voice, this one may send voice, okay, so no error control for these channels, but channel 3 send data, so it needs error control, okay. What it can do is that it can have other protocol, for example, okay, so this is user number 3. Okay, user number 3 may use Hdl-C frame format, okay, Hdl-C protocol. So you will have flag and address, okay, address and control, and then information, and then FCS, and then flag, okay. Then what you do is that you will send like the first byte you send in the first frame, right? And then suppose address use 8-bit too, you send to the second frame, okay? Let's say control use 16-bit. It will have half of it into this frame and half into another frame, right? So in terms of the TDM frame, this is a TDM frame. Number 1, number 2, number 3. In terms of TDM, it doesn't care what is in the where the data in the frame come from. The data in the frame may come from voice, may come from image, may come from like a file, okay? So this one just send, the TDM just send. However, in terms of user can decide what to send in each of the slot, okay, in the slot that is assigned for. So if this one use flag, address, control, at the other end, at the receiver, when it received this data, it can reconstruct the Hdl-C frame, right? So when it get the Hdl-C frame, then it can do the error control, use FCS here, right? It can use the frame check sequence to check whether it received correctly or not. So the error control is done in a per channel basis, okay? So channel 3 want error control, channel 3 will just use error control. Other channel doesn't want error control, the other channel doesn't have to use error control. Okay, you understand? Okay. Now, so that's all for the TDM. The next topic is multiple channel access, okay? In this case, we want to share okay, it's a technique we want to share for multiple transmitter, multiple receiver stations, okay? this is what we call FDMA and TDMA, which is FDMA and TDMA. And what are the difference? It's different from the FDM and TDM because there is no use of physical multiplexer. So if there is no multiplexer that move like this, okay, in the TDMA and FDMA, there's no, okay, this one you have a multiplexer, right? FDM and TDM you have a multiplexer. But in FDMA and TDMA, there is no multiplexer. So if it is the frequency division multiple access, okay, each station is assigned a frequency band. So different stations have different frequency band. If it's time division multiple access, each station is assigned a sequence of time slot. Okay, so, and then it can transmit directly on the channel. There are also other access like CDMA, code division multiple access, okay, but we are not covered here. Have you heard of Hush Company? The telephone Hush Company? That is, I think it's no more. Have you heard? When there used to be like AIS and then DTAG and then Hush. Have you heard of it? Okay. Hush used another technique called CDMA, code division multiple access. Okay, but since we are not using it right now, okay, I'm not putting it in a sheet. Okay, you can come and ask if you want. Okay, anyway, so there are many ways to do the multiple access. For frequency division multiple access, okay, we will have different uplink frequency for each of the user. Suppose you have a base station, okay, one base station and many subscriber stations. So this may be the mobile phone, or it may be the notebook, okay, or satellite networks, okay. I already correct the typo here, okay, there's no M here. I update the file on the on MaxLearn already, okay, but I cannot connect into the Wi-Fi. So this is the old version, okay, but the one that is correct is in the MaxLearn, okay. Now the base station, we assign different bandwidths, okay, so this is called uplink. S1 use this uplink frequency to upload its own data. For example, it may send the image, upload an image, okay, to the base station, okay. S2, S3 also use different uplink frequency. And between the uplink frequency, there is guard band, okay. Guard band is to prevent the spilling of the spectrum, okay, between the two frequency bands. For the downlink, okay, you have only one common downlink frequency. That is from base station to every subscribers. Okay, so only one downlink and many uplink frequency band. Each of the band is for one users. For the guard band, okay, you can see that this is the frequency axis. Okay, so if you draw it like this, this is the frequency, okay, and if you have a channel, okay, so this is the guard band, okay, the guard band. So suppose this is channel 1, channel 2, channel 3, okay, okay, and this may be the downlink. Okay, so if you send a spectrum, okay, if you don't have a guard band, if it's the guard band is 0, you see that it is possible that there's some spillage over, okay, from this channel to this channel. It will become interference, okay, between two channels. So, but if you have guard band, it will not interfere with the other channel. The spectrum will not interfere, okay? So that's why we have the guard band here. Now, let's look at the characteristic of the FDMA, okay? Each sub-channel is used by only one single station, so it's assigned that this frequency is for station A, this frequency is for station B. So when the base station received the information, it will look which frequency it comes from. If it's the frequency for user 2, number 2, okay, then the base station will know that, oh, okay, this comes from user number 2. It doesn't have to identify user number 2 because it's already agreed that user number 2 will use this sub-channel frequency band. So look at the frequency that it received if you know who sent it. Okay, because it's like if I give Pecharapan one frequency band, give Ankana another frequency band, right? So when I see, if I'm at a base station and I see the frequency band, the frequency that I receive, I will know from the frequency who is sending to me, okay? So that is how we do it, okay? But if the station does not use it, suppose you have nothing to send, no one else can send that because it's already agreed that this frequency is only for this subscriber, okay? So you have a problem, okay? Capacity of the channel is wasted if the station does not use it, okay? So similar to the synchronous TDM. It's less complex, estimate is less complex than the TDMA because the TDMA has involved with the time, okay? So you have to be like exact, right? That, okay, you speak for a minute, like the example last time. So if you look at the time, you know who is speaking. But if you speak and you don't keep the time, right? If you speak more than your slot, then you have a problem, right? It means that you are not synchronized. Okay, you don't keep the time. If you have only 1 minute, you have to not talk over 1 minute, right? And also your clock has to be synchronous. So everyone clock has to be synchronous for the TDM, remember? TDM, if